Hi, this is Danny Tang. I'm doing the probability and stochastic processes homework 6, problem 1. Problem 1 gives you the joint density function f of x and y as b times x times y on the interval 0 or x is greater than 0 but less than y, and y is greater than y is greater than x or less than 1, and it's 0 otherwise. So number 1 says find b, and the bounds of y are from 0 to 1, and bounds of x are from 0 to y. So all you do is double integral of the f of x and y function, set it equal to 1 using the bounds I wrote on the board, and after doing the integration you find that b is 8. So number 2 says find and sketch the marginal density functions f of x and f of y, a small f of x, small f of y. All you do is, for small f of x, you do the integral of f of x and y with respect to dy, and with this your bounds would be from x to 1, and the answer you get is 4x times 1 minus x squared inclusive. And similarly for f of y, you do the integral with respect to dx, and the bounds are from 0 to y, and the answer you get is 4 times y cubed. And sketching these two for y of x, it's just a curve starting from 0, and then it's a parabola, and for f of y, it's just a curve going upwards. And for C, it asks you to prove or disprove that x and y are independent. So if they're independent, then that means the marginal density functions, when we multiply them together, you would get the f of x and y density, joint density function. But we can see that this is clearly not the case. So we say that x and y are not independent. For part D, it asks us to find the expected values of x, y, and x times y. So for this part, you would take the integral of x times the f of marginal density f of x, and the bounds are from 0 to 1, and when you do this integral, you find that expected value of x is 8/15. And for x of expected value of y, you would do integral of y times marginal density f of y, and the bounds are from 0 to 1, and the answer we get here is 4/5. And the expected value of x and y would be the double integral of x times y times the joint density function using the bounds that I used in part A, and you find that the value is 4/9. And for part E, it says prove or disprove that x and y are uncorrelated. So based on the formula for correlation, correlation is covalence of x and y over the square root of the variances, two variances. So to find out if they're uncorrelated or non-correlated, you have to find the covariance. So inserting the values that we found in part D, you would, following the formula that covariance is expected value of x and y minus expected value of x times expected value of y, you would find that it does not equal 0. So therefore x and y are not uncorrelated. In part F, it asks us to find conditional density functions f of y given x and f of x given y, and all you do is using the formula f of y given x is equal to the joint density function over f of x, and then you would get 2y over 1 minus x squared. Similarly, the joint density, conditional density function f of x given y is the same way, except the denominators is f of y, and then that would be 2x over y squared. And to plot this, you will have to fix the denominator. So basically this, since you're plotting f of y given x, you really only care about 2y. So you would consider the rest of it a constant, and then you would just get a straight line. And then same thing for f of x given y. So it's pretty much the same plot. And lastly, part G, it asks us to find the conditional expected values. And so expected value of big Y given small x is just using the formula y times joint density, and then you do the integral with respect to dy with the bounds from 0 to 1. You find that it's 2/3 times 1 over 1 minus x squared. And for x of big X given small y, you would do the integral of x times the joint density with respect to dx from 0 to 1, and that integral comes out to be 2/3 times 1 over y squared. For expected value of big Y given big X, you would just use the values we found in part D. So that equals expected value of x and y over expected value of x. That gives you 5, 6. And expected value of big Y given big X, you write it the same way, except the numerator is expected value of x, or expected value of y, and then you the value you get would be 5/9.